AQA Paper 2 from Practice Paper Set 1. Question 1. Here is a linear sequence, 5, 13, 21 and 29. Circle the expression for the nth term of the sequence. Now the first thing to note is that the sequence goes up in eighths each time. There's going to be a real temptation to try and circle the answer n plus 8 because of this, but that is wrong. Because the sequence goes up in eighths, this means it's based on the 8 times table. So this is the first term, this is the second term, the third term and the fourth term. If we write out the 8 times table, 8, 16, 24 and 32, if we were looking at the nth term, the formula for the 8 times table would be 8n, but we're not quite there. As you can see, these terms are 3 less than the corresponding terms in the 8 times table, so the expression that we want is 8n minus 3. Question 2. Circle the fraction that is equivalent to 0.05%. 0.05% would be 0.05 over 100. If we then multiply the numerator and the denominator by 100, we get to 5 over 10,000, which we can then simplify down to 1 over 2,000. Question 3. A straight line has equation y equals 6 take away 2x, circle the gradient of the line. If we compare this to y equals mx plus c, where m is the gradient, we can see that the gradient is -2. Question 4. Y is directly proportional to x and k is a constant. Circle the correct equation. The correct equation is y equals kx. Question 5. Jack and Kylie are asked to work out this calculation to 2 decimal places. Jack's answer is 0.22, Kylie's answer is 30.76. How have they obtained these answers? Is either answer correct? If you type this calculation correctly into your calculator, you will find that the answer to this is 0.219545, so 0.22 to 2 decimal places. Jack is correct. You now have to explain what Kylie managed to do as well in order to get the last mark in the question. Now Kylie did this. So she multiplied 9.8 by 12.1 square rooted, then divided by 19.4, and then added 30.2. So she did not follow the correct order of operations, as we all know that the 19.4 and the 30.2 need to be added together before the division occurs. Question 6. Part A. Solve the inequality 3x is less than or equal to 18. Divide both sides by 3 gives us x is less than or equal to 6. 6. Part B. Solve this inequality. If we multiply out the brackets, we have 4x plus 8 is greater than 12. So 4x is greater than 4 if we subtract 8 from both sides. And if we then divide by 4, we get x is greater than 1. Part C. Represent the solution set that satisfies both answers to parts A and B on the number line. So x is greater than 1, so we want an open circle on 1. X is less than or equal to 6, so a closed circle on 6, and a line joining up these two. If you draw this above the number line, it makes it clearer than if you try and draw it on top of the number line. Question 7. This formula works out the tax you pay. T equals 0.2 bracket E minus 10,600. T is the tax in pounds, E is the amount you earn in pounds. Alison pays 5,200 tax, so this is equal to T. So we set up an equation, 5,200 equals 0.2 e minus 10,600. If we divide both sides by 0.2, we get 26,000 equals e minus 10,600. We then simply have to add 10,600 to both sides of this to get a value for e. And e is equal to 36,600. Question 8. Solve x squared equals 30.25. So we need to square root 30.25, remembering that we have to take a positive and a negative root. Note that there are 2 marks available here, so to get our 2 marks we have to write down the 2 possible answers, 5.5 or negative 5.5. A neat way of summarising this would be x equals plus or minus 5.5. Question 9. Here are 2 piles of the same type of paper. Each sheet of paper is 7/1000ths of a centimetre thick, and the taller pile is 10.5 centimetres high. The height of the taller pile to the height of the shorter pile has a ratio of 3:2. So that is a ratio of 3 for the taller pile to 2 for the shorter pile. Now, we know that 10.5 centimetres is the height of the taller pile, so one of these units must equal 10.5 divided by 3, which is equal to 3.5, which means that the smaller pile, which is made up of 2 of these, must have a total height of 7 centimetres. Now, we know that each sheet of paper is 7/1000ths of a centimetre thick, so the number of sheets of paper is the total height of the shorter pile, 7, divided by the height of one sheet of paper, 7 over 1,000, which of course is equal to 1,000. So there are 1,000 sheets of paper in the second pile. Question 10. Here are 4 triangles, and in 10 part A we have to decide which 2 triangles are in fact congruent to each other. So all the triangles have some similar numbers, 5 centimetres, 3 centimetres and 30 triangles, and what we should hopefully notice straight away is that we have a side of 5 matching a side of 5, a side of 3 matching a side of 3, and an angle of 30 degrees enclosed between them, which means that B and C are the congruent pair. Now, the reason for that is, of course, SAS, side, angle, side, with the angle enclosed between the 2 sides. Question 11. You're given the formula for the volume of a sphere, 4/3 pi r cubed, where r is the radius, and identical spheres of radius 9.5 centimetres are packed tightly into a cuboid. So we can label some of this information on the diagram. Plan view, that means from above, so that distance there is 9.5. So the diameter would be equal to 19 centimetres, and then we have the front view of the cuboid here below. Work out the total volume of the spheres in the cuboid. So the volume is equal to 4/3 times pi times 9.5 cubed multiplied by 4 because there are 4 spheres. This comes to a value of 14,365.456, etc. So we can round that. We can round that down to 14,365 centimetres cubed to the nearest 1 centimetre cubed. 11 part B, work out the volume of the cuboid. Well, we know that the cuboid looks a bit like this. from the plan view we knew that there were 4 spheres, and from the front view we could see 2, which means that there must be 4 spheres inside the cuboid. Now, the diameter of one sphere we said was 19 centimetres, so this distance here, which is 2 spheres diameters worth, is 38 centimetres. The height of the cuboid has got to be the diameter of one of the spheres, which is 19 centimetres. And again, across here, there are 2 spheres worth, so that's 38 centimetres. So the volume of the cuboid is 19 multiplied by 38 multiplied by 38 again. And this comes to a value of 27,400 centimetres cubed. Part C. Work out the total volume of the spheres as a percentage of the total volume of the cuboid. So we have to do volume of spheres divided by the volume of the cuboid and multiply this by 100 to convert it into a percentage. So the volume of the spheres, we're going to use the unrounded value of 14,365.456 over 27,400 and multiply that by 100. This comes to a value of 52.428 ... So our answer is going to be 52.4% to 3 significant figures. Question 12. In this question, all lengths are in centimetres. Given that the ratio of A to B is equal to 1 to 2, show that AC to BC is 3 to 4. So AB is 3x minus 9, and BC is 5x minus 11, and the ratio of these is 1 to 2. Now you can see, hopefully clearly from here, that this side is double this side. So 5x minus 11 has to be equal to 2 lots of 3x minus 9. Solving this, 5x minus 11 equals 6x minus 18, expanding the bracket. Then if we add 18 to both sides, 5x plus 7 is equal to 6x. Subtract 5x, giving us 7 equals x, or x equals 7. We now need to show that AC to BC is 3 to 4, so we're going to work out the values of AC and BC. AC is equal to 2x plus 4, which is equal to 2 lots of 7, plus 4, which is equal to 18 centimetres. BC is equal to 5x minus 11, which is 5 times 7, subtract 11, which is equal to 35 take away 11, which is 24 centimetres. So we now can work out the ratio of AC to BC as 18 to 24. This is a ratio that can be simplified. Divide both sides by 6, and we then get 3 to 4. Which was what we were required to show. Question 13. A menu has a choice of 3 starters, 5 main courses and 4 desserts. How many different choices of a 3-course meal are possible? So for each one of the 3 starters, there are 5 main courses possible, and for each of those 5 main courses, if we just pick one of them, for example, there are 1, 2, 3, 4 desserts possible, so that's 3 multiplied by 5 multiplied by 4, which is 60 possible combinations. Question 14. Triangle has vertices at A, B and C. The triangle is reflected and points A and C do not move. We need to draw a sketch diagram of this, which doesn't mean that we need to plot anything accurately, but just sketch where the points are. So A is about here, B is about here, and C is here, and notice C and A are on the same level because they both got a y coordinate of 1. If the triangle is reflected and points A and C do not move, that means the line of reflection has got to be the line y equals 1. Question 15. The area of a right-angled isosceles triangle is 4 centimetres squared. So it's isosceles, which means that these two sides are the same length. Work out the perimeter of the triangle in centimetres. Give your answer in the form a plus b root c, where a, b and c are integers. So the key piece of information here is that the area of the triangle is 4 centimetres squared. We call this side x and this side x. We can say that a half x squared is equal to 4. A half times base times height equals 4 centimetres squared, the area. We need to multiply both sides of this equation by 2, so x squared equals 8, and this then gives us x equals the square root of 8, which is equal to 2 root 2, because root 8 is root 2 times root 4, which is 2 root 2. We then need to work out the hypotenuse of the triangle. We'll call it C. This side would be A and this side would be B. If we apply Pythagoras Theorem, a squared plus b squared equals c squared, then we know that x squared plus x squared is equal to c squared. Now we already know that x squared is equal to 8, so we could just write 8 plus 8 is equal to c squared. This means that c squared is equal to 16 and c equals 4, the hypotenuse. So the perimeter is equal to 4 plus x, which is 4 plus 2 root 2 plus 2 root 2, which is 4 plus 4 root 2. Question 16. On the 1st of January 2012, Beth invested some money in a bank account. The account pays 2.5% compound interest per year. On the 1st of January 2013, Beth withdrew £1,000 from the account, and on the 1st of January 2014, she had £17,466 in the account. Work out how much money Beth originally invested in the account. The originally invested means that we are trying to work out the amount we started with, which means this is some sort of reverse percentage type question. So, January 2012, let's say she started with X pounds. By January 2013, this would have gained some interest. We would have multiplied by 1.025, which is the percentage multiplier for a 2.5% increase. Now, before we get to 2014, £1,000 was withdrawn from the account, and we then get to 2014, which is another year, which means we multiply by 1.025 again. And this gets us to our final value of 17,466. We now need to reverse all of these steps. So starting with 17,466, we need to divide this number by 1.025, then add 1,000 to that number and divide by 1.025 again, which should take us back to our starting value of x. If we complete that on a calculator, so 17,466 divided by 1.025 will equal 17,040 pounds. £17,040 add £1,000 equals £18,040. £18,040 divided by 1.025 is equal to our final answer of £17,600, which was the starting amount. Question 17. The probability that Gina goes to the gym on Saturday is 0.9. The probability that Dave goes to the gym on Saturday is 0.6. These probabilities are independent. Calculate the probability that both of them do not go to the gym. We're going to draw a quick tree diagram. The first set of branches represents Gina. She either goes to the gym or she doesn't go to the gym. The next set of branches represents Dave. And the probabilities for Gina, the probability she goes to the gym is 0.9, so the probability that she doesn't go to the gym is 0.1. For Dave, the probabilities are 0.6 for going to the gym and then 0.4 for not going to the gym, and these probabilities are independent of Gina's probabilities. The probability that they both do not go to the gym, we need to access this path here, not and not, which means we need to do 0.1 multiplied by 0.4, which is equal to 0.04. Part B. If Gina goes to the gym on Saturday, the probability that she goes on Sunday is 0.2. If she does not go to the gym on Saturday, the probability that she goes on Sunday is 0.7. Calculate the probability that Gina goes to the gym on exactly one of the 2 days. There's a big blank space here, which is a suggestion that we might want to draw some sort of diagram, i.e. a tree diagram. This time we're only worried about Gina, and we're worried about what happens on Saturday, and then afterwards what happens on Sunday. Now, she either goes to the gym, or she doesn't go to the gym. In either case. The probability of her going to the gym on a Saturday, we know from part A, is 0.9, so the probability of her not going to the gym is 0.1. If she goes to the gym on a Saturday, the probability that she goes on a Sunday is 0.2, which means the probability she doesn't go on a Sunday, if she went to the gym on a Saturday, is 0.8. If Gina does not go to the gym on a Saturday, i.e. following this path here, the probability that she goes on a Sunday is 0.7. So if she doesn't go on a Saturday, the probability that she does go on a Sunday is 0.7. The probability that she doesn't then go on the Sunday is 0.3. We want to know the probability that Gina goes to the gym on exactly one of the 2 days. Now, that means we want her to go to the gym here, but not here, or she doesn't go to the gym on Saturday and she does go to the gym on Sunday. So the calculation that we need to do is 0.9 multiplied by 0.8, which is this branch here, plus 0.1 multiplied by 0.7, which is this branch here. So this then comes to a final value of 0.79. Question 18. The height h of a particle at time t is given by this function here. Draw a graph to show the height of the particle in the first 10 seconds. We need a table of coordinates here. Time, which goes up to up to 10 seconds, and h, which we can calculate. Now, when the time is between 0 and 2 seconds, but not equal to 2 seconds, i.e. whether it is 0 seconds and 1 seconds, the height is 0. After that, the height is calculated using this formula here. So we have to substitute in these values of t, using our calculator, into this formula to calculate the height. So for instance, if t equals 2, then h is equal to 14 minus 2 multiplied by 2 minus 2, which of course is 12, multiplied by 0, which is 0. And we have to repeat the same for 3, 4, 5, 6, 7, 8, 9, 10 onwards. If we do that, we find these values here. We now need to plot these coordinates, h on the y-axis and t on the x-axis, on the set of axes provided. Once the coordinates have been plotted, as shown, a smooth curve needs to be drawn through them. Part B. By joining the points on the curve where t equals 3 and t equals 7 with a straight line, work out the average rate of change of height between 3 and 7 seconds. So, from where t equals 3, which is this point here, and t equals 7, which is this point here, we need to join them up with a straight line. Please use a ruler to do this. And it's then important that we find the gradient of this chord that's been drawn. So we draw in our right angled triangle. We know the base of this triangle goes from 3 to 7, so that's 4 units. The height of this triangle goes from 11 through to 35, so it's a height of 24. So the average rate is the gradient, which is 24 over 4, which is 6 centimetres per second. Question 19. In this question, use 1 pound equals 0.4536 kilograms, 1 inch equals 0.0254 metres. The pressure of a basketball is 7.5 pounds per square inch. Work out this pressure in grams per square centimetre. So we know that 1 pound is equal to 0.4536 kilograms. We're dealing with 7.5 pounds, so we need to multiply 0.4536 by 7.5, which gives us 3.402 kilograms. Now our final answer needs to be in grams, so we need to multiply this by 1,000, because there are 1,000 grams in a kilogram, which gives us 3,402 grams. We now need to convert this bit here. So we're dealing with 7.5 pounds per square inch. So we know that 1 inch is equal to 0.0254 metres. Now our final answer has got to be in square centimetres, so it makes sense to convert this calculation in metres into centimetres by multiplying by 100. So that is 2.54 centimetres. So 1 square inch is equal to 2.54 squared square centimetres. If we work out what 2.54 squared is, that's 6.4516 square centimetres. So we've now converted 7.5 pounds per square inch. We know that that is the same as 3,402 grams per 6.4516 square centimetres. However, we need to convert this into grams per 1 square centimetre, so we need to convert this into 1 centimetre squared, which means this value here, we need to divide it by 6.4516. This gives us 527.311 ... So our final answer is 527 grams per centimetre squared, to 3 significant figures. Question 20. The speed of 50 vehicles was measured travelling along a road. Each driver travelling at more than 70 miles per hour is fined £60. On average, 8,400 drivers use the road each day. Estimate the total amount of money raised from fines on the road each day. So we haven't got information about all 8,400 drivers. We have information about a sample of 50 drivers and the speeds at which they were driving along a road. We use that sample and we use proportionality to work out an estimate for how many of the 8,400 drivers were travelling at more than 70 miles per hour. So if we look at this, we know that in these categories here, these drivers were definitely travelling at above 70. This category here, some of these drivers were driving above 70. So if we think about how this would be split up in a graph, we've got 60, 65, 70 and 75. And that's 24 drivers split across here. If we assume that they were all evenly split up, that's 8 drivers between 60 to 65, 8 between 65 and 70, and 8 who were travelling between 70 and 75. So that's 8 to include with this 9 and the 4. So 4 plus 9 plus 8 comes to a total of 21. So that's 21 drivers out of the 50. That's the proportion who would be travelling at more than 70. If we multiply that by 8,400, that will give us the number of drivers out of the 8,400 we estimate to be travelling over 70 miles an hour. That's 3,528. We need to work out how much of a fine they would get. So that's 3,528 multiplied by 60. And that comes to £211,680. Mia says 4% of the vehicles on the road travel at 40 miles an hour or less. Explain why she might be wrong. Now, Mia has got this statistic from the table. Looking at the vehicles that travel at 40 miles an hour less, that's 2 out of 50, which is 4 in 100 or 4%. Now, that's true of the sample. It doesn't necessarily mean it's true of the whole population of cars. It's quite a small sample. It may not represent the population in full. Question 21, part A. Write x squared minus 10x plus 29 in this format here. This is the process of completing the square. So we start with x minus 5 all squared, and the minus 5 of course comes from halving the negative 10 here. Now if we expanded this, x minus 5 all squared, x minus 5 multiplied by x minus 5, which is x squared minus 10x plus 25. We need to ensure that we turn this positive 25 into this positive 29, so we have to add a 4 at the end. So our final answer is x minus 5 all squared plus 4. 21 part B. A sketch of y equals x squared plus cx plus d is shown, and the turning point is 3, 5. Work out the values of c and d. To do this, you need to remember the connection between turning points and completing the square. If that's the turning point, the minimum point, its completed square format, or the completed square format of the function of this graph, must have been x minus 3 all squared plus 5. If we expand this, and simplify, we can then find out what c and d are. So this is x squared minus 6x plus 9 plus a 5. So that's x squared minus 6x plus 14. Now remember, the graph was y equals x squared plus cx plus d. C is minus 6, reading from here, and d is positive 14. Question 22. Two triangular lawns are surrounded by fences as shown. The lawns are also separated by a fence. Work out the total of the 5 fences. Now, this triangle here is right angled, which means that we can use standard trigonometry or SOHCAHTOA to find this side here and this side here. this is our angle, 40 degrees. This side here is the hypotenuse, it's opposite the right angle. This side here is opposite 40, so it's the opposite. And this side here is then the adjacent. Now, I'm going to first of all calculate the opposite. I'm going to use the hypotenuse of 100 metres. So if I look at my SOHCAHTOA triangles, the only one that's got O and H in it is this one over here. And I can say that the opposite is equal to S times H, or sine 40 multiplied by 100, which comes to this value here. I'm now going to work out this value here, the adjacent. I'm going to use H, which was given to us. We have just worked out O, but in case we made a mistake, it's better to use the values that we were given in the question, i.e. this H value of 100. This time, I'm going to need to use Ca, or cosine, because I have H and I'm trying to find out A. So A is equal to C times H, so that's cos 40 multiplied by 100, and that comes to this value. I now have nearly all of the values I want, apart from this one over here. Now this second triangle is non-right angled, so we can't use standard trigonometry in SOHCAHTOA. We're going to have to use a different rule. Now, we have this angle here, 30 degrees, which is enclosed in a V shape between these two sides. We know that this one here is 64.27 and this one here is 120, so we can use the cosine rule to work out this missing side here. We'll call this little a, and then this capital A, and then this side can be B and this side can be C. Now the cosine rule is one of the formulae that we have to memorise, and it tells us that a squared is equal to b squared plus c squared minus 2bc cos a. So that's 120 squared plus 64.27 ... squared minus 2 times 120 times 64.278 ... times cos 30. If we input this into our calculator, we get the following value. And a is then the square root of this number, which is 71.914 ... We do not round any of these values until the end. The total length is then equal to 120 plus 64.278 ... plus 76.604 ... plus 100 plus 71.914 ... which gives us a total of 432.797, which will round to 433 metres to 3 significant figures. Question 23. The cumulative frequency diagram shows the time taken by runners to complete a half marathon. On the grid opposite, draw a histogram to represent the data. Use this table to help you. So, we've been given 4 blank columns. We're going to use all of them. The first one is for cumulative frequency. So, going up to 100, we can read off that the cumulative frequency from there would be 8. Going up to 120, we can then read off that cumulative frequency as well, which gives us 56, and we can continue to read off all of the cumulative frequencies for each of these upper boundaries. So look up 160, 200 and 300, and the cumulative frequencies are 100, 110 and 120. What we can then do is work out the frequencies for each of these categories. So from 8 to 100, there were obviously 8 people. Now, the cumulative frequency going up to 120 from 80 was 56 people. Now, 8 of those people belonged to the 80 to 100 category. So to work out the frequency of the people in the group 100 100 to 120, we have to do 56 minus 8, which gives us 48, and so on. For the next group, 100 minus 56, which gives us 44, 110 minus 100, which is 10, and then finally 120 minus 110, which is 10. Remember that cumulative frequencies are running totals of the frequencies. You're doing the opposite of what you normally do to calculate cumulative frequency. The question asks us to draw a histogram, which means we need to remember our formula that frequency density, which is what we plot on the vertical, on the y-axis of a histogram, we need to remember that frequency density is frequency divided by class width. So we need a column for class width and then finally a column for frequency density. The class widths are easy to work out. The first group runs from 80 to 100, so that's 20. 100 to 120, so that's 20. Then we have 40, 40, and finally 100. Frequency density is then equal to frequency divided by class width. So if we work out each of those, we get 0.4, 2.4, 1.1, 0.25 and 0.1. We can then plot the bars on this graph here. One key thing to remember is to label the axes. So the vertical axis will of course be frequency density, write it out in full, and the horizontal axis will be time, and you then draw each of the bars to the correct height. You don't have to start at 0, you can break the axis and start at 80.